You just joined a new project or inherited one. The repo has 200,000 lines of code. The last developer left 8 months ago. There are no tests. The docs are outdated. Nobody knows what is safe to change. Just don't touch the billing module, somebody says. You open the codebase and ask yourself, where are the bugs hiding? What is a security risk? How bad is the technical debt? Where do I even start? You need a map. SonarQube is that map. SonarQube is an open-source platform that continuously inspects and analyzes code quality to detect bugs, vulnerabilities, and code smells in your projects. It supports many languages and integrates into CI/CD pipelines, making it a standard tool for maintaining high code quality in teams. There are 2 main ways to use SonarQube. SonarQube Cloud, formerly Sonar Cloud, zero configuration, seamless integration with GitHub, free for open source projects. Private repositories are also supported for free with limitation to 50,000 lines of code. And SonarQube Server, self-hosted via Docker, requires setup and maintenance. Self-hosted solution, so giving you full control over your data and environment. Free community edition available, with paid editions for additional features. How to use SonarQube? There are 3 main integration paths, ABC, and we will cover all 3 in this talk, starting with the easiest one. So the SonarQube Cloud, fully automated, no infrastructure needed, run on every push and pull request. SonarQube plus GitHub Actions, so CI/CD pipeline with self-hosted instance. And SonarQube CLI, manual work, run the scanner locally from the command line. I prepared a demo repository for this talk, which contains a simple Node.js application with some intentional code issues to demonstrate SonarQube's capabilities. The easiest way to get started is to use SonarQube Cloud, which is fully managed service that requires no setup or maintenance. At the beginning, you need to register your account at sonarcloud.io. After registration, you can sign in and create organization. Then select the repository you wanted to analyze. Connect your GitHub repository to SonarQube Cloud. After connecting, SonarQube Cloud will automatically set up a webhook in your GitHub repository to trigger analysis on every push and pull request. After a few seconds, of course it depends on the size of the codebase, you can view the results of all branches and pull requests directly on the dashboard. On the GitHub pull request profile, you will see SonarQube Cloud comment with information about issues which are reported by the Sonar Cloud code analysis. Let's move on to the more hands-on approach with a self-hosted SonarQube instance. At the beginning, it may seem more complex to set up and maintain, but it gives you full control over your environment and data. Both B and C will use the same local SonarQube instance, so we will start with that. After the beginning, we need to set up a local SonarQube instance. We will use Docker for that, which makes it easy to run and manage. After that, I need to wait for the server to start. It may take a few minutes, especially on the first run. Then I can access the dashboard at localhost 9000 and log in with the default credentials. I need to change the default password on the first login, and then I can generate an authentication token which will be needed for both B and C. Go to My Account, Security, type any name, and choose Global Analysis Token. Copy the token because it is shown only once. Next step is to expose the local SonarQube instance to the internet so that GitHub Actions can access it. I will use ngrok for that, which creates a secure tunnel to the local server and provides a public URL. You can use whatever tunneling tool you prefer, for example, local tunnel. I will check the public URL provided by ngrok and use it in the next step. Everything is ready for the next part. Let's set up a GitHub Actions workflow to run SonarQube analysis on every push and pull request. First, we need to create a Sonar project properties file in the root of our repository with the following content. Then we need to configure the repository secrets and variables in GitHub. In Settings tab, please open Secrets and Variables, then Actions. First of all, we need to create Sonar token. It's a token generated from the local SonarQube instance. After that, we need to create the first and only one variable called Sonar host URL, which will be the public URL generated by ngrok, all local tunnel. Then we need to create a workflow file in our repository at .github/workflows/SonarQube YAML with the following content. After commit and push, the workflow will be triggered on every push and pull request to the main branch. Now we can open the SonarQube dashboard at the public URL and see the results of the analysis. We can see the code quality issues, bugs, vulnerabilities, and code smells detected by SonarQube. As you can see, layout in free edition is quite basic, but it still gives you a good overview of the code quality. Finally, let's see how to run the SonarQube scanner manually from the command line without any CI/CD integration. In this step, we will use the same local SonarQube instance, but instead of GitHub Actions, we will run the scanner directly from our terminal. We will use the Sonar Scanner package, which can be installed globally or run with npx. Before running the scanner, we need to create the same Sonar project properties file as in the previous step. We need to pass the SonarQube server URL and the authentication token as parameters to the scanner. After running the command, the scanner will analyze the code and send the results to the SonarQube server. Note that Java runtime is required to run the SonarQube scanner, so make sure you have it installed on your machine. In the dashboard, you can see a view of the code quality issues, and you can also see the history of analysis and trends over time. On the last slide, I will share some useful resources for learning more about SonarQube and its features. Thank you for watching. I hope this talk helps you get started with SonarQube and improve the quality of your code bases. Bye bye.